Hi, Chris Kuzmal here. Last time we completed the idea of rotation without thinking or looking at code. And the process began with a tree that looks like this, and we conceptually raised a node. There's no code that does this. This is just conceptually raising it. But the first thing that we do with code is to cause the right child of LCX to become the left child of X. And so we're going to reset the right child for the left, rotate. Okay, so that's the name of the method that we're going to quickly look at now. And so we switch over to code. And here's the rotate left method. Okay, it takes a binary search tree and a node. And we have three helper methods. The first is resetting the right child for a left rotate, which is what we just saw. And the code for that takes a node, gets its right child, and places it into a temporary variable called old NR, the old n's right child. And it takes the left child of old NR and makes that the right child of n. That's what my 115 does. If the left child of old NR is not null, then we make the left child of old NR. Excuse me, we make N to be the parent of the left child of old NR. And then for purposes of our method, for purposes of the overall rotation, we return old NR because we're going to need that for the subsequent helper methods. So that's the code for a helper method for the rotate left version of rotation. So we need a rotate right version that'll have a similar effect as this. And all that helper code is doing is, excuse me, is shifting this pointer from here to here. This is all that code is doing, all right, basically. And so that's resetting the child. In subsequent videos, we'll look at what the other two helper methods do, and I'll flash through what they do here. Okay, and actually I should do this in slideshow mode, excuse me. So we shift that today, and then in future videos, we'll look at this other sequence, which we've looked at before, but I just thought I'd show it to you. And so after we do this shift, the next thing we're going to do is we need to properly connect X's parent to what was X's child. So X's parent is this thing up above, which normally isn't in our diagrams, but X has a parent, typically, even if it's the root, or even if X is the root, X's parent is null. So we still need to do the process of shifting these two pointers and accounting for whether or not X's parent is indeed nil. So let's take a quick look at the code if we have time for that, okay? So this is links n's parent to old NR. That's what this shift is doing, okay? And so we take the node n and take the node what was our right child and then the binary tree. And we make it so that we get the parent of n and we make that the parent of old NR. So we're shifting it to make the case that our old child now has our parent, and that's what this does. If that's null, then we have to make the root of the tree old NR, and that's what happens here on line 122. All right. If this isn't null, then we need to check to see which child of the parent we are and set the left child, okay, of the parent to old NR. If we are the left, if N was the left child, if N was the right child, we need to set the right child. And that's what the second helper method, link N's parent to old NR, does.